क्लास नाइन्थ चैप्टर 8 मोशन स्टार्ट करते हैं। इन एवरी लाइफ वी सी सम ऑब्जेक्ट्स एट रेस्ट। ये सब तो पढ़ना जरूरी नहीं है, यहाँ से पढ़ते, यहाँ भी, यहाँ से motion along a straight line. The simplest type of motion is the motion along a straight line. We shall first learn to describe this by an example. Consider the motion of an object moving along a straight path. The object starts its journey from O, which is treated as its reference point. Let A, B, and C represent the position of the object at different instants. At first, the object moves through C and B and reaches A. Then it moves back along with the same path and reaches C through B. The total path The total path length covered by the object is OA plus AC. That is 6 km plus 35 km or 95 km. This is the distance covered by the object. To describe distance, we need to specify only the numerical value and note the direction of motion. There are certain quantities which are described by specifying only their numerical values. The numerical values of a physical quantity is its magnitude. From this example, you can find that the distance of the final position C of the object from the initial position O. This difference will give you the numerical value of the displacement of the object from C to O to C through A. The shortest distance measured by the initial to the final position of the object known as the displacement. Shortest displacement measure from the initial distance from the initial final position of the object known as initial. When the magnitude of the displacement to be equal to the distance traveled by the object, consider the example given. The motion of the object from O to the A. The distance covered by 60 km and the magnitude of the displacement is also 60 km. During this motion of 0 to A back, the distance covered 60 becomes 85 km. While the magnitude of displacement 35 km, thus the magnitude of displacement 35 km is not equal to the path length 35 km. Further, we will notice that the magnitude of the displacement for a course of motion may be 0, but the corresponding distance covered is not 0. If we consider the object to travel back to 0 or final position considered with the initial position and there so the displacement is 0. However, the distance covered in the journey is O plus 60 km, 120 km. Thus, two different physical quantities, the distance and the displacement, are used to describe the overall motion. The object location, the final position, the reference point, initial position, the time. Automobiles are fitted with a device that show the distance traveled. Such device is known as odometer. डिस्टेंस को ओडोमीटर से ट्रेवल नापते हैं, मेजर करते हैं. डिस्टेंस को ओडोमीटर से भुवनेश्वर में डिस्टेंस बिटवीन द रीडिंग ओडोमीटर फाइंड द मैग्नीट्यूड डिस्टेंस बिटवीन भुवनेश्वर एंड न्यू दिल्ली. ओडोमीटर डिस्टेंस को ओडोमीटर से मेजर करते हैं. डिस्टेंस ओडोमीटर Uniform motion and non-uniform motion. Consider an object moving along a straight line. Let it travel 50 km in the first hour. 50 km more in the second hour, 50 km in the third hour, and 50 kilometer in fourth hour. This case the object cover 50 kilometer each hour. The object cover equal distance is equal interval of time. It is said to be uniform motion. This time interval this motion may be small or big. In our day-to-day life, we come across motion where object cover unequal distance in equal interval of time. For example, a car is moving on a crowded street or a person is jogging in a park. These are some instances of non-uniform motion. Non-uniform motion. Look at the Look at the situation. Give the boiling speed of the 40 kilometer. What does the mean? What do you understand from the signboard? Understand from the signboard. लगा चलिए पढ़िए different object may take different amounts of time cover a assigned distance. Given distance, some of them move the faster, some move slowly. The rate of which object move can be different. Also, different objects can move at the same rate. One of the ways of the rate of movement an object is to find that the distance traveled by object in time spent. It is referred to as speed per unit of speed is meter. Speed is meter per second, 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 meter per second. This is represented meter square include centimeter per second, and kilometer per hour, kilometer per hour. To specify the speed of an object, we require only its magnitude. The speed of an object need not be constant. In most cases, object will be in non-uniform motion. Therefore, we describe the rate of motion of such objects in terms of their average speed. The average speed of an object is obtained by dividing the total distance traveled by the total time taken. Average speed, total distance by time, distance by time, and speed over distance by time, distance by speed over distance by time, distance by time. Here traveled a distance time t speed given s by t. Let us understand this by example. A car travel a distance of x kilometer into hour. Its average speed is 50 kilometer. 50 kilometer per hour. The car might not have traveled at 50 kilometer per hour at all the times. Sometimes it might have traveled faster and sometimes traveled very fast. Speed with direction. The rate of motion of an object can be more comprehensive if we specify its direction of motion along its speed. The quantity that specifies both these aspects is called velocity. Velocity is the speed of an object moving in a definite direction. The velocity of an object can be uniform or variable. It can be changed by changing the object speed, direction of motion, or both. When an object is moving along a straight line at a variable speed, we can express the magnitude of its rate of motion in terms as average velocity. It is calculated in the same way as we calculated average speed. In case the velocity of the object is changing at uniform rate, then average velocity is given by the arithmetic mean of initial velocity and final velocity given period of time. Velocity, initial velocity, final velocity बटे 2 u plus v by 2 u plus v by 2 average velocity u, the initial velocity is v, the final velocity is the speed of velocity of same units, that is meter per second, meter per second, minute, meter per second, meter per second, meter per second, meter per second, meter per second. Rate of change of velocity during uniform motion of an object along a straight line. The velocity remains constant. Velocity remains constant. कोई भी ऑब्जेक्ट यूनिफॉर्म मोशन में चलता है तो वेलोसिटी क्या रहता है, कांस्टेंट रहता है. टाइम के साथ वेलोसिटी विथ टाइम के साथ वेलोसिटी कांस्टेंट रहता है. यूनिफॉर्म मोशन में टाइम के साथ वेलोसिटी कांस्टेंट रहता है. वेलोसिटी कांस्टेंट यूनिफॉर्म मोशन के साथ वेलोसिटी कांस्टेंट रहता है. इन केस चेंज वेलोसिटी object interval time, any time is 0, zero the uniform non-uniform motion, velocity varies time with different distance, different points of path. Thus the change in velocity of object during any time interval is not zero. Uniform motion varies with time, different values at different instants and different points of the path. Thus the change of velocity in the time interval not zero. Hello. Hi BPC teacher aspirant. कहती मैम का नहीं देखते आप, अच्छा ठीक है. नहीं अभी फ़िलहाल नहीं देखते. एक बार एनसीईआरटी पढ़ने के बाद फिर देखेंगे. एक बार 10th तक पढ़ लें, उसके बाद फिर देखेंगे फिर 8 क्लास से, 8 क्लास या 7 क्लास से. To answer such a question we have to introduce another physical quantity called acceleration, which is the measure of the change in the velocity of an object per unit time. Object per unit time. Measure change velocity in the object unit time. Velocity and acceleration change in velocity time taken. Acceleration change in velocity time. Acceleration time with the velocity of object and initial velocity, final velocity, acceleration. Initial value and final value is the time. This kind of motion is known as accelerated motion. Acceleration is taken to positive and the direction of velocity is negative. Acceleration is taken positive and direction of velocity is negative when the opposite to the direction of the velocity. अपोजिट डायरेक्शन में पॉजिटिव होता है और डायरेक्शन वेलोसिटी के डायरेक्शन में पॉजिटिव होता है और डायरेक्शन अपोजिट डायरेक्शन में वेलोसिटी का अपोजिट डायरेक्शन में नेगेटिव होता है. SI unit of acceleration meter per second square, meter per second square, meter per second square, meter per second. SI unit of acceleration meter per second square, meter per second. If an object travels in a straight line and its velocity increase or decrease by equal amounts in equal interval of time, travels in a straight line and its velocity increase and decrease in equal amount of equal interval time, then the acceleration of the object is said to be the uniform. The moon is freely falling body. Motion is free falling body. Motion is free falling body. The uniformly accelerated motion on the other hand, object can be travel with the non-uniform acceleration. Its velocity change at a non-uniform rate. Velocity change a non-uniform rate. For example, if a car traveling along a straight road increases its speed by an equal amount on equal interval of time, then the car is said to be moving with a non-uniform acceleration. Non-uniform acceleration. Non-uniform acceleration attain the velocity of 6 meters per 30 seconds. Then the flight breaks on such a velocity bicycle to fall into and the next. That was the acceleration bicycle is yes. Graphical representation of motion graphs provides a convenient method to present basic information about a variety of events. Example, the telecast of a one-day cricket match. Vertical graphs are also the run rate of team match or the isolated static mathematical state like help showing linear equation of the motion. Describe the motion of an object. We can use line graphs. In this case, these line graphs, show dependence of one physical quantity such as distance or velocity on other quantity such as time. As distance or velocity on another quantity such as a time. Distance time graph. Distance time graphs. The change in the position of an object with the representation of the distance time graph. Graph independence is sketched by the graph time taken along with the x-axis and the distance is taken with the y-axis. Distance time graph can be employed under various conditions in order to move with an uniform speed, at rest. Uniform speed, non-uniform speed remain rest. Uniform speed, non-uniform speed. X-axis and time x-axis, x-axis and distance y-axis, distance y-axis. इसमें क्या होगा स्पीड होगा time and axis, distance and axis of the uniform and uniform motion. Distance time graph is moving uniform speed. Distance time graph uniform speed. We know that the object travel distance equal to interval time. Distance equal interval time. Uniform speed. Equal distance equal interval of time. Equal distance equal interval of time. Uniform speed. This distance traveled by the object is directly proportional to time taken. Distance traveled by the object directly proportional to the time taken. Directly proportional to the time taken. There is no time taken. Thus, uniform speed as a graph distance travel against the time straight line. So, figure the proportion OB of the graph so that the distance is increasing at a uniform rate. Note that you can also use the term uniform velocity, uniform speed if the the magnitude of displacement equal to the distance traveled by the object along the axis y-axis. We can use the distance time graph. We can use distance time graph to determine the speed of the object. To do so, consider a small part AB of the distance time graph. Now we draw parallel to the axis of the another turn parallel of the y-axis and meet the graph into the time distance and time constant overcomes in the time speed of the distance time graph accelerated motion. We can show distance time graph is the time interval times a second. The distance time graph for the motion of the car is known as the speed of this graph is different from the either distance time graph for uniform motion. The nature of this graph shown non-linear variation of the distance traveled by the car with time. This graph shown figure represents motion with uniform non-uniform motion. Velocity time graph the variation of velocity graph. Velocity is time for an object moving with a straight line can be represented by the velocity time graph. Velocity time graph. In this graph, this is represented along the axis, and the velocity is represented along the y-axis. If the object moves at uniform velocity, the height of the velocity time graph not change with the straight line parallel to the axis. So the velocity time graphs are moving with a uniform velocity 40 km per hour. We know that the product of velocity and time gives displacement, and the moving uniform velocity. The area enclosed by velocity time graph and the time axis will be equal to the magnitude of the displacement magnitude of the displacement. To know the distance moved by the car between the time t and t2 with uniform drawn perpendicular from the point corresponding to the time t1 t2 on the graph between velocity of 40 km per hour and the distance moved parallel to the we can also estimate the uniformly expected motion by plotting its velocity time graph. Consider car will drive the straight road testing its again. Suppose the person sitting driving and velocity after every 5 seconds the velocity speedometer the velocity of car in speedometer as well as in the calculated different instant time वहाँ ना वो चावल भी लगा बिस्तर पे in this time velocity time graph iron motion in this case velocity graph iron motion of the car is figured the nature of the graph and velocity change the equal amount of equal interval time and velocity change by the equal amount of equal interval time and the uniformly accepted motion. Velocity graph is straight line. Velocity graph is straight line. Velocity time graph is straight line. Velocity time graph for the moving with uniform acceleration. You can so determine the distance moved by a car from its velocity time graph area under the velocity time graph. Velocity time graph is distance, magnitude, displacement, distance, and magnitude of displacement, magnitude of displacement moved by the car at given interval time. If the car have been moving with uniform velocity, distance traveled by the represented by the area ABCD under the graph. Change the magnitude of velocity fast or changing the acceleration, change due to acceleration, change due to acceleration. Distance traveled by the given area ABCD under velocity time ग्राफ में acceleration होता है velocity time ग्राफ में acceleration होता है वेलोसिटी टाइम ग्राफ में एक्सीलरेशन होता है और डिस्टेंस टाइम ग्राफ में स्पीड होता है डिस्टेंस टाइम ग्राफ में स्पीड होता है इन दिस केस यूनिफॉर्मली स्पीड एक्सीलरेटेड मोशन वेलोसिटी टाइम ग्राफ इज एनी शेप velocity time graph represents the motion of object velocity decreasing motion of represents motion decreasing and the time by the represents the uniform non-uniform variation velocity object the intention
दूसरा वाला करता है बात कुछ
equation of motion by graphical method when an object moves along a straight line with uniform acceleration it is possible to relate its velocity acceleration during motion and the distance covered by its certain time interval by set equation known as the equation of motion. There are three such equations. V बराबर U प्लस ए टी 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 S बराबर U टी प्लस हाफ ए टी स्क्वायर S बराबर U टी प्लस हाफ ए टी स्क्वायर 2AS V स्क्वायर 2AS V स्क्वायर माइनस ए स्क्वायर 2AS V स्क्वायर माइनस U स्क्वायर where U is the initial velocity which moves uniform acceleration from the velocity and the distance traveled over time. The velocity time velocity is the reference position of the conjecture and velocity continuum. Equation for velocity time relation. Equation for velocity time relation considers the velocity time graph is on the uniform acceleration uniform velocity time graph. Velocity time graph uniform acceleration. So one is similar to that how with you for this graphs when you see that initial velocity of the object is u at t point a then it increases to v at point e in time t. The velocity changes at a uniform rate a. The perpendicular time bc and be are drawn from point b on the time and the velocity axis represented so that the initial velocity is represented by OA. The final velocity is represented by BC and the time interval T and represented by CBC. The time distance and the parallel and equation for position of time relation. Consider travel distance time under uniform acceleration. Distance travel by the object of time the area velocity time graph the distance travel the object. It is called equation of the position velocity relation. Position velocity relation. Position time relation. टाइम रिलेशन में ये वाला फार्मूला लगेगा एस बराबर यू टी प्लस हाफ ए टी स्क्वायर एंड पोजीशन वेलोसिटी रिलेशन 2as भी स्क्वायर माइनस यू स्क्वायर पोजीशन the velocity relation, position velocity relation of the velocity time graph and the distance traveled by the object in uniform acceleration given interval within the if the carefully notes during the release some stone move along a straight line in circuit and pass this speed once the instant release will continue to move along the direction it has been moved at the instant. This shows that the direction of motion changes at every point when the stone was moving along the circular path. When an athlete throws a hammer or a discus, the sports meet the holds a hammer, discus, and art under with circular motion rotation of the body. Researchers describe the motion of the hammer, discus of the direction, and the release of the stone of the describe and the familiar of the under information such as the motion move and the satellites and the circular orbit circular constant speed as shown. Motion is change of position is can describe the position of the situation movement of the uniform, non-uniform velocity is constant change the distance over the time to velocity and displacement per unit time acceleration of the time velocity per unit time uniform non-uniform is a function of two graphs in the uniform quantum where u is initial and moving with the uniform acceleration of t and the velocity of the distant velocity object on the uniform speed. Motion is called uniform circular motion. Circular path, uniform speed, circular path, uniform circular motion, uniform circular motion, uniform circular motion. Figure 3 v बराबर ए टी v बराबर u प्लस 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 ए टी s बराबर v टी प्लस हाफ ए टी स्क्वायर s बराबर u टी प्लस हाफ ए टी स्क्वायर 2as v स्क्वायर माइनस u स्क्वायर 2as v स्क्वायर माइनस u स्क्वायर वेलोसिटी टाइम ग्राफ में एक्सेलरेशन होगा वेलोसिटी टाइम ग्राफ में एक्सेलरेशन होगा और डिस्टेंस टाइम ग्राफ में स्पीड होगा डिस्टेंस टाइम ग्राफ में स्पीड होगा यूनिफॉर्म मोशन में रिमेन कांस्टेंट वेलोसिटी यूनिफॉर्म मोशन में वेलोसिटी कांस्टेंट रहेगा यूनिफॉर्म मोशन में वेलोसिटी कांस्टेंट रहेगा नॉन यूनिफॉर्म मोशन में नॉट जीरो मतलब अनकांस्टेंट रहेगा नॉन यूनिफॉर्म में अनकांस्टेंट रहेगा उसको एसआई यूनिट ऑफ स्पीड मीटर पर सेकंड स्पीड एसआई यूनिट मीटर पर सेकंड स्पीड एसआई यूनिट मीटर पर सेकंड स्पीड एसआई यूनिट मीटर पर सेकंड डिस्टेंस मेजर ओडोमीटर स्पीड मेजर स्पीडोमीटर डिस्टेंस मेजर ओडोमीटर चलिए तो 10 क्लास चैप्टर 8 मोशन चैप्टर आज ख़त्म हो गया और कितना चैप्टर बचा ये हो गया मोशन तक हो गया 1 2 3 4 5 6 7 चैप्टर है 2 यानी 3 दिन में इसको ख़त्म करना है 3 दिन में 9th क्लास को ख़त्म करना है ये सब तो हो गया अच्छा फोर्थ लॉ ऑफ मोशन ग्रेविटेशन वर्क ये 2 दिन में पढ़ेंगे ये 2 दिन में फिर ये 2 दिन में ख़त्म हो जाएगा 3 दिन में इसको ख़त्म करना है उसके बाद 10 क्लास में एंट्री करेंगे 3 दिन में इसको ख़त्म करके 10 क्लास का NCERT पढ़ेंगे। बहुत टाइम लग रहा है, बहुत टाइम लग रहा है इसमें। 7 क्लास से स्टार्ट किए हैं, आज 9 क्लास में है। 9 क्लास का 8 चैप्टर में। चलिए फिर आधे घंटे के बाद घटना चक्र में मुलाकात करते हैं।